Here is a question from NET JRF 2019. This is question number 21. In this question, it is given that an object is dropped on a cushion from a height 10 meter above it. On being hit, the cushion is depressed by 0.1 meter. Assuming that the cushion provides a constant resistive force, the deceleration of the object after hitting the cushion in terms of acceleration due to gravity is equal to, option A is given as 10g, option B is given as 50g, option C is given as 100g, and option D is given as g. So let's solve this question. For solving this question, this is the related diagram for this given question. Let this is a position A, which is initial position of the object, and B is a point on the question. So for solving this question, first we will apply the energy conservation principle. So from the energy conservation principle, gives us the total energy at initial point, means E I will be equal to total energy at final point EF, which provides us the kinetic energy at initial points, means initial kinetic energy plus potential energy at initial point. Initial potential energy equal to will be kinetic energy at final point plus potential energy at final point. Now, as the object starts its motion from A, and at the point A, its velocity v is equal to 0. Therefore, we can write its initial kinetic energy will be half into m into 0 square plus its initial potential energy equal to mg multiplied by its height, which will be equal to its final kinetic energy, and its final kinetic energy is given as half m v square plus its final potential energy is given as mg into 0, because on the cushion its height is considered as datum level. At datum level, its height is equal to 0. Therefore, we can write v square is equal to 2gh. So we can write v equal to under root 2gh. Now we'll consider the equation of motion. So from this diagram we can draw an FBD. So if this is the point, if we take a point here, then its deceleration will act upward. So its value of deceleration will be m into dv with respect to dt. It acts upward, and its downward force is equal to, one is mg and another mg, and the resistive force will act upward. So this is the value of resistive force K. From this diagram or from this FBD, we can write the equation of motion. So if we write the equation of motion, then it will become m into dv with respect to dt minus, which is equal to mg minus k. From this equation, again if we divide this equation, so let this is our equation number 1 and this is our equation number, and if we rearrange this equation, or if we divide this equation by m, then it will become dv with respect to dt equal to g minus k divided by m. So this is our equation number 2. Now, as we know this dv with respect to dt can be written in the form of dv with respect to dx into dx with respect to dt, and again this dx with respect to dt is nothing but velocity. Therefore, we can write this dv with respect to dt will be equal to v dv with respect to dx. Therefore, from our equation number 2, this equation number 2 becomes v dv with respect to dx, which is equal to g minus k divided by m If we again cross multiply, this equation will become VdV, which is equal to G minus K divided by M into dx. Now if we integrate this equation from both sides, then the initial limit of v velocity, means when this is at the object is just on the question, its velocity, its value of velocity equal to under root 2gh, and at the final point its velocity becomes 0, and its corresponding displacements, initial displacement is equal to 0.1, because it is provided in the equation in our question, and its final displacement is equal to 0. Now, as we know, the derivative, the integration of vdv is equal to v square divided by 2, and its limit, lower limit is equal to under root 2gh, and its upper limit is equal to 0, which is again equal to g minus k divided by m into x with limit 0.1 to 0. Therefore, we can, again, this equation can be expressed as, because g minus k by m is representing its the acceleration, therefore we can write this value will be equal to 0.1 will be equal to 0.1 into a, and if we calculate the left hand side, then it will become 0 minus 2gh divided by 2, which is equal to 0.1 a. Now this 2 and 2 will get cancelled. If we cancel this 2 equation, then we can write the value of a will be equal to minus gh divided by 0.1. But from our given question, it is given that the object is dropped from a height of 10 meters. So value of h is equal to 10. Therefore we can write this equation will become g multiplied by 10 divided by 0.1. Therefore, the value of a means the acceleration will be equal to 100 minus 100 g. So among these four options, first option is equal to 10 g, second option 50 g, third option 100 g, and fourth option is z. Therefore we can write our correct option is option C.